Identify the chemical reaction and write the balanced equation. The reaction between nitrogen monoxide gas and oxygen gas to produce nitrogen dioxide gas is represented by the equation. 2NO plus O2 gives 2. Number 2. Examine the stoichiometry of the reaction. Notice the molar ratio of the gaseous reactants to gaseous products. On the reactant, left, side, there are 3 moles of gas, 2 moles of NO plus 1 mole of O2. On the product, right, side, there are 2 moles of gas, 2 moles of number 2. This means that as the reaction proceeds to completion, every time the reaction occurs, 3 gas molecules are consumed to produce only 2 gas molecules, leading to a net decrease in the total number of gas molecules in the vessel. Relate the number of gas molecules to pressure using the ideal gas law. The ideal gas law is defined as PV equals nRT. The problem specifies that the reaction occurs in a rigid reaction vessel, meaning volume, V, is constant, and at a constant temperature, T is constant. Under these conditions, pressure is directly proportional to the number of moles of gas particles. P is proportional to N. Determine the pressure change. Because the total number of gas molecules, N, decreases as reactants are converted into products, the frequency of molecular collisions with the walls of the container must also decrease. Conclude the correct option. A lower collision frequency results in a decrease in the pressure inside the vessel because there are fewer molecules of product than reactants, making option B the correct choice. The correct answer is option B. The pressure will decrease because there are fewer molecules of product than of reactants.